Welcome to Yurix AI. This is Lecture 6 of LLMs from Scratch, Zero to Builder. I'm absolutely thrilled to have you here today because we're finally transitioning from just understanding the theory behind large language models to actually drawing up our blueprint to build one from the ground up.
Here's our roadmap for today's explainer. We've got 1. The big picture, 2. Stage 1, basics, 3. Stage 2, pre-training, 4. Stage 3, fine-tuning, and finally, 5. The complete playlist roadmap. Let's dive right in.
Section 1, the big picture, the 3 stages of building an LLM. Building a massive AI model from absolute scratch sounds like something only huge tech companies can pull off. But it really doesn't have to be intimidating. The entire build is just 3 stages. That's it. Step 1, stage 1, the basics. Step 2, stage 2, pre-training. And step 3, stage 3, fine-tuning. So keep this simple blueprint in mind. It is literally your map for everything ahead. And if you stick to it, you'll never get lost in the code later on. Section 2, Stage 1, LLM Basics and Foundations, the building blocks of language models. So you can't just feed raw English text into a computer, right? It has to be meticulously processed first. And this brings us to tokenization. By definition, this is breaking down sentences into individual units, or tokens. Think of it like chopping up raw text into words, or even parts of words, so the computer can actually process it. Without this crucial first step, the model just sees a meaningless wall of characters. Okay, once we have our tokens, we need vector embedding. Basically, this means transforming those chopped up words into actual numbers, so similar concepts group together mathematically. For example, because of vector embedding, the semantic meanings of words like apple, banana, and orange will end up mathematically closer together than they would to words like football or golf. We're essentially teaching the computer the meaning of a word based entirely on its numeric coordinates. How cool is that? Next up, we have the attention mechanism. This allows the LLM to selectively access the whole input sequence to weigh word importance. To really grasp this, think of reading a complex mystery novel. You might pay super close attention to a tiny, seemingly insignificant clue in Chapter 1, right? Because suddenly it becomes incredibly important in Chapter 10 to solve the crime. The attention mechanism does exactly that. It lets the model look back at the entire context of previous words to perfectly predict the next word. It's essentially what gives the model its memory. Now, when we assemble the architecture that houses this attention mechanism, it's really important to note that modern GPTs rely exclusively on a decoder architecture. The original transformer model, which totally revolutionized AI back in 2017, actually had 2 halves, an encoder and a decoder. But modern generative pre-trained transformers, what we all know as GPTs, well, they only use the decoder. It's streamlined, it's highly efficient, and it is wildly powerful. Moving on to Section 3. Stage 2, pre-training the LLM, building the foundational model. So once our data is prepped and our decoder architecture is fully set, we take all of that and train a massive generic foundation model on an absolute ocean of text. During this heavy training phase, we use what's called an epoch. An epoch is simply a full pass through the entire training data to compute gradients and update the model's parameters. The model iterates through massive amounts of unlabeled data, literally billions of words, epoch after epoch. And honestly, this requires an unbelievable amount of compute power. Just to give you some perspective, pre-training GPT-3 cost around $4.6 million just in computing costs alone. Now, there's a massive difference between where we are right now and where we're going. Let's look at the comparison. Pre-training uses unlabeled data, billions of words, is highly expensive, and it builds a broad, general foundational model. Fine-tuning, on the other hand, uses labeled data, specific applications, smaller data sets, and is highly targeted. You see, pre-training gives the model its vast, generic knowledge of human language, but fine-tuning, that's where we pivot to making the model actually useful for specific, real-world tasks. Which brings us perfectly to Section 4, Stage 3, fine-tuning the LLM, creating specific, production-ready applications. The reality in the tech world is that almost nobody deploys a raw, pre-trained foundational model directly to users. Why? Because they're just too generic. They are always fine-tuned for specific tasks. For example, if we build a spam classifier, we input labeled email text, and the model is strictly trained to output spam or no spam. Or for a personal assistant chatbot, the input is an instruction and the output is a helpful chat response. By giving the model carefully labeled data in this fine-tuning stage, we get the exact desired outputs we need. And finally, Section 5, what the whole playlist will cover, the complete roadmap ahead. All right, so here is what's waiting for you in the rest of this explainer series. We're going to be doing hands-on coding directly in Jupyter Notebooks. We'll be building our data batches completely from scratch. We'll also get to witness emergent properties, which, by the way, is completely mind-blowing. It's when an AI, trained only to predict the next word, suddenly figures out how to translate languages or summarize text all on its own. And thankfully, we're going to learn about saving and loading pre-trained weights so we don't have to spend millions of dollars computing from scratch. Starting in our very next lecture, we're going to dive deep into the code together, proving that by following these 3 stages, you can actively build everything you've just learned. So before we sign off, let's look at a quick final recap. Your builder's blueprint is just 3 stages: basics, pre-training, and fine-tuning. Stage 1 gets our data chopped up and our architecture ready. Stage 2 builds that massive foundational knowledge. And Stage 3 focuses that broad knowledge into a specific, highly useful application. Keep this simple blueprint in your mind and you will absolutely master LLMs. Thank you so much for joining me on this incredible journey today. Now that you know the 3 stages to building an AI brain from scratch, I want to leave you with this. What specific application will you fine-tune first once you have the power to build it? Think about it. Like, share, subscribe to Yurix AI for a new lecture every day, hit the bell,